So I just received this message from Clay confirming that Code Labs is officially listed on the expert page. So to say thank you, I prepared probably one of the most complicated workflows that I built, and I'm gonna break down everything that I did here and give basically everything away for free. But this particular workflow gave us such a big output internally that we started using it for every single client that we manage at Code Labs. I've probably spent like 10 hours building this, and I've outlined a whimsical diagram to illustrate like what we're doing here so you can see the big picture. But I've outlined the big benefits of why we started implementing this internally. First of all, it helps, like this Clay template helps us deliver to Outlook emails. And I'm going to show you why I say this like quote unquote, but we also get over 90% coverage on our lead lists. So this means that we, from 10,000 companies, at least 9,000 of them, we have at least one person to reach out to in the company, which is significantly higher than before. Like before we used just a poll and we got 35 to 50% coverage because you have so many companies that you can reach out to. But when you run them through all the different big database platforms, you end up with like half of them are going to waste because you cannot, either you identify people from the company, but you cannot find a valid email, or you cannot even get one person from the company. The other benefit is that we get significantly less hallucinations compared to just using ClayGen to qualify companies. And it's incredibly cost efficient. Like some of the AI models that you see here, when we run them for 10,000 roles, the charge is like 30 cents, which is completely ridiculous. So this is going to be a big overview, but if you want all the details, like all the prompts, all the formulas, you can let me know in the comments. I'm going to give you like the 20-minute video breakdown of how I built the entire workflow. So we're starting off with just a basic company table. When you scrape companies, let's say you get the company name, the company domain, LinkedIn URL, description, industry, that's what we're doing in here. Like we're just outputting the data that we're getting from the scraping tools. The first thing that we do is we verify the company domain. This is super crucial because if you don't have the final company domain, the official company domain, or you get it wrong, you get wrong contacts from the company and you will be unable to find the right email addresses of the decision makers. So what we do here, the first thing is we check if the URL is valid to make sure that this is the actual, like the URL is working. That's basically from the Clay native integration. I love this so much. Like shout out to Clay for building this. The second one is we check if the content of the domain matches the company name. It shouldn't be an exact match. That's why we have a prompt, but it basically scans the content that we have on the company domain and the company name, and it checks if they're completely irrelevant, it's going to output that this is not the right company domain. Because you see most of the times, if you scrape, especially if you scrape data from LinkedIn, for example, this company, I got it from my lead list directly. This company, Your Analytical Partner Consulting. By the way, I don't know the company, I just thought it's a relevant example. If you take a look at this company on LinkedIn, the company LinkedIn URL, you'll see that this company has listed, instead of their company domain, they just put the Calendly link so you can directly schedule a call with them. But when you scrape it from LinkedIn, the company domain is going to say it's calendly.com. And then you have two completely different companies. So from here, if you just leave it like this, you're going to get completely wrong contacts at the wrong company, and then you have irrelevant messaging, which is what I very much try to avoid at all costs. So these two run, and then if it's not valid, or if the company domain does not match the company name, we have two ClayGen prompts. The first one runs with GPT-4 Omni to find the company domain, and this one probably costs like $7 per 10,000 rows. But if the confidence level for this one is low or it's not high, we have a fallback option to go with more expensive models. So that way we know that we get like the biggest possible coverage. We then merge the domain, normalize the domain, and this one is important, especially if you have to do lookups in between different tables. Like I'm going to show you why this is important in a second. And what we do next is something that's really cool. Like that gave us such a big output, and like it made the company qualification process so much more accurate just by changing this one. What we do is once we have the final company domain, we scrape the HTML code of the homepage of the website. So what happens, let's say for Code Labs, if I scrape my own website, in the result, you will see that we have the homepage content, but we have it in a markdown format. So we are able to get all the logos, all the links, all the buttons on the company page. So what we do in here is I get all of this content, put it into Gemini 1.5 Flash, which costs basically nothing. You see that it basically costs, I don't know, $2 per 10,000 rows, something like this. And what we get from here are 4 relevant pages on the company website that basically has a lot of context about the business, what the company does. So we get up to 4 relevant pages. We get the LinkedIn company page, and we get phone numbers from the company website. Once we have this, we check if the company LinkedIn URL is provided. If not, we run a ClayGen for fallback so we can get the biggest coverage. We scrape the LinkedIn with an HTTP request. We use ICP's APIs. We get all the details, like we get the LinkedIn company description, the about section, how many people work at the company. And then additionally, we scrape the 4 relevant pages from here. We get the links. Once we have all that data, we check in our do not contact list to make sure that these company domains do not exist in our do not contact list. What we do is we have 3 different integrations, because I always want to check by company domain, company name, and company LinkedIn URL to make sure that I don't miss any company here. We get the DNC, and if the company is not in our do not contact list, what we do is we scrape all these 4 pages that are relevant, that contain a lot of information about the business. So I'm going to go back to the whimsical diagram so you don't lose track. But what we did was we scraped the HTML, we scraped all the links, emails, and phone numbers on the company website on the homepage. We found the relevant pages. We found the LinkedIn. If we didn't find it on the homepage, we searched with ClayGen using Boolean searches. We scraped the company LinkedIn URL. We checked all of this in our DNC list. And if they don't exist, if the companies do not exist in our DNC list, we scrape all the relevant pages that we scraped from here. So once we have all the pages scraped, I put them into another AI model using Gemini 1.5 Flash. This one again costs $2 per 10,000 rows. And I get the core offerings, the pricing options listed on the company website, the company function, competitive advantage that this company has, and who they target. These are 5 different things that we scrape for. We summarize all the content, and then we put all of this into a company qualification prompt. So if I go back to the whimsical diagram, we scrape all of the pages, we summarize the content of all pages, and then we qualify the companies for a fit. I have 3 different categories that I get in the output from the company qualification prompt. One of them is reasoning. I need a fit category. If they are a bad fit, I have 3 different categories: qualified, manual check, and disqualified. These are basically the 3 different outputs that I want from the AI model. If we get that the company, like if we see that the company is for a manual check, the AI model couldn't take a decision, we get a notification inside of Slack. So we get a message, we see which company needs a manual review, and then we can manually mark this one. However, if we see that the company is qualified, we scrape people from 4 different data sources. So we use all the big players like Apollo, ZoomInfo, we scrape all of them, we dedupe them into a people table, and we search for valid emails. So we move to the people table. If I go back, we move all of them into a people table. We see if these people exist in our do not contact list. We create a lookup so we can get all of the data from the company table into the people table. So we create a lookup, we make sure that we get all the data. And then we scrape the LinkedIn profile of the person, because most of the big database platforms, like they're great for finding contacts, but I see that there is like a very big gap because they don't update their databases often. So you can end up like with outdated data, contacts that no longer work at the company. So you want to make sure that you avoid this. The way we do it is we scrape the LinkedIn profile of the person. We use Rapid API for this one. And then we qualify the person for a fit here. So do they still work at the company? And is the job title qualified to receive the message that we are planning to send? If they do, this checkbox here, ICP is going to output true. And then what we do here is like the biggest breakthrough that I make. For some of you, it's going to sound obvious, but like this gave us such a big output in here. So what we are doing here is we are trying to find the work email for that individual. So we run a waterfall enrichment. We try and find this person's email address, and we try to get the biggest coverage. We validate the emails, and then we verify the ones that are catch-all using instantly catch-all verifier. Once we have the email address, we check the MX record to see, is that email Google? Are they using Microsoft? Are they using SMTP? If they're using Outlook or Microsoft Inbox, what we do is we have a fallback, and we search for the personal email address of the person. So this one runs. If it finds a personal email address, we verify the email, and then we validate the catch-alls. Now, once we have this, we clean the foundational data, meaning we clean the first name, the company name, and the job title of the person, and then we push them to a relevant campaign. Now, the workflow doesn't stop here. And like the biggest breakthrough that I found was actually in the company table, because what we identified And this was shout out to Valentin from my team, by the way, because he came up with this concept. Because we were having some companies that we couldn't identify at least one person from the company, even though we run all of these enrichments. So what we tried to do was, if we couldn't find at least one person with a valid either personal email or work email, what we do is we try to search for company emails or emails that are like generic support@info@ emails. And if you think that we're ridiculous, I have proof about this. These are two identical campaigns that we've launched. The copy was the same. The companies were completely identical. Both of them had 1,500 contacts in them. The first one was using generic company emails, and we get 7.1% reply rate and 23 opportunities. The second one was using decision maker email addresses. 1,500 people, 38 replies, 4.2 reply rate, and only nine opportunities from this list. So this clearly works. It depends on the industry, but we've seen this as a very big advantage that we make. So what I do is I go back to the company table, and we create a lookup. Where was it? Lookup from the people table to see if we have at least one person from the company. If we don't have at least one person from the company, what we do is we launch a campaign with generic emails. And then additionally, because we see like that's one great example that I can show you, we have one company, which is, give me just one sec. For example, this company, the final domain. If we search this company up on Apollo, you see that we have contacts in here. But if I go to the contact page on the company website, you see that we have a staff directory and we have a bunch of decision makers, the CEO, the president, the operations support manager. If I copy this name and I paste it in here, you will see that Apollo does not have this data. So all of the contacts that were in here with email addresses were unable to find from the big database platforms. So what we do instead is we again use the script content from the homepage of the website, which uses like the HTML code of the homepage. We put it into another AI model that just searches for the links that likely contain decision maker information or company level information. We scrape these pages, and in the output, we put it into another AI model that searches to find other decision makers from the company that we were unable to find from like the big database platforms. And as you can see, we have 8 different contacts in here, all of them with full name, job title, phone number, LinkedIn profile, and we push them to another table so we can get like, this is what I call like the biggest possible coverage. So just to give a recap, we search for and qualify the companies for a fit. We find and identify decision makers from 4 different big database platforms. And if we are unable to find, we will search for contacts listed on any of the contact pages on the website. And as a fallback, we use the generic company email addresses left on anywhere on the company website. So this is just a big overview of the Clay table that I've built. But if you want to go and like, if you want to see this in depth, every prompt that we've built, all the integrations that we're using and how we constructed the Clay table, you can let me know in the comments below. And then I'm going to send you, I have like a 20-minute video that I sent internally on how to use the whole Clay table. So yeah, let me know if that was helpful, and thank you so much.